Hello everybody. So a few months ago I got myself a Harbor Freight Lathe. And then a couple of weeks ago I was trying to turn something a little bit too heavy. I didn't think it was too heavy, but I mean it's maybe 10 pounds I guess. Maybe 10 pounds with the thing on the back. But it burned out my motor. After doing a little research afterwards, I found that the Harbor Freight Lathe is actually very underpowered. I'm not upset though. When you buy Harbor Freight, you take these chances. So I just happened to burn out my motor on something that should have been super easy. But as I said, once I started reading more about it and seeing different reviews, I see that the motor is pretty underpowered. It rates at 3/4 horsepower on the box, but most people are of the consensus that it's about 1/3 horsepower, which is not nearly enough for anything more than small pieces of wood. Anything more than 2 pounds will bog it down, apparently. So as I said, I'm not particularly upset. I had a lot of fun with it while it was working, and now it gives me the opportunity to replace the motor. Now I could just get another motor, the same motor that goes in it, and plop it right in, but it would still be an underpowered 1/3 horsepower motor, when I could upgrade it and add more power. So that's what I'm going to do. So I did a lot of research, looking around, and I found a lot of instructables, YouTube videos, web pages on people who have had the same issue and upgraded their lathe with a new motor. The problem was all the videos were missing something, and I had to search through multiple sources. I had to track down like how to mount the motor, how to build the circuit, and they were all missing something. So what I'm going to do is I'm going to try and compile everything I have and everything that I found into one video or set of videos. So I don't know if the term limb vac is used in the civilian world. I'm going to guess not. But in the military, a limb vac is a limiting factor. What is stopping you from accomplishing the mission fully? So I see 3 limb vacs in front of me. 1, I don't know what I'm doing. I've never done anything like this before, but I can figure it out. 2, I have very little experience with metal work, and I'm going to need to do some metal fabricating to build the mount. And 3, I don't know how to weld. And a lot of the videos that I saw, people were welding up different things to build a mount. I don't have a welder. Even if I did, the last time I welded anything was in middle school shop class. So I'm going to have to figure out how to mount it with the tools that I have and the materials that I can get that require no welding. So that should be fun. Okay, now because of the scope of the project, I want to split it into 3 different videos to give as much detail as to my process as possible, so anybody following afterwards will have a better idea of what they can do. Now this isn't going to be a perfect build, but this is going to be the best that I can do with the materials and tools that I have available to me, which is not a lot. Like for the metal work, the most I really have is a grinder and a drill, and that's going to be most of, yeah, I got an angle grinder and a drill. So we'll see what I can come up with that. So yeah, I'm going to break it down 3 videos to provide a more in-depth guide on how to upgrade your Harbor Freight 12x36 lathe from a 1 horsepower POS motor to a 2.25 horsepower DC motor. So since this is the first video, let's get started with the electronics. Okay, so here's the schematic that I drew up. Now I drew this based on a lot of the online tutorials that I saw, and I also added a couple things in there to upgrade it a little bit. Alright, so we'll start with power cord. This was actually a, oh, that's not it. This was actually a 7 outlet power strip that I just cut the end off of. Yeah, so that's right here. This is the AC power in. Then we go on to the switch, and I got a big, beefy on-off switch. So yeah, this thing it'll handle a lot of power, but I just thought it looked cool. Okay, and that's the switch here. Now from the switch, the AC power is going to go right over here to this 12 volt power supply. This is a little different than most of the online ones that I've seen, because this will power the tachometer. Boom. Now, most of the online tutorials that I've seen for the tachometer, they don't even put in how to wire it and how to put it up. So but what I did see is it looked like people were powering it separately from the lathe. They would turn on the tachometer and then turn on the lathe. I wanted to find a way to include it in the lathe circuit, so my primary switch turns on everything. And to do that, I found this. This is basically just a 12 volt power supply. Kind of like, it's just the same thing for any little plug you have for your different devices and everything, but it's something that can be wired up into a circuit. So it's going to go into here, and the tachometer is going to be wired to here, and then the power is going to go right back out again into the voltage controller. Now this voltage controller is the same thing that's used in every single tutorial that I found. It was the same voltage controller. This is, I think, a 10,000 watt controller or something like that. It was ridiculous. But this is an AC voltage controller. It's not made for DC. Now on the front end, it has a 500 kilo ohm potentiometer, which is right here. This I'm going to swap out because this voltage controller is made for both 120 volt and 240 volt, and so this potentiometer is really meant for 240 volt applications. So I got a 200 kilo ohm potentiometer that I will replace this with, so you have a more fine control. If you left the 500 on, then you'd get over halfway before it even turns on. With this, you'll have a lot more fine control, so you start it, as soon as you start turning, it'll start turning the motor. Okay, now out of this, remember this is for AC only. This is going to feed into this. This is called a bridge rectifier right there. Now this bridge rectifier basically turns your AC power to DC power. So you get that in there, wired up, and everything coming out of this will be DC and ready for the motor. Now from here it's going to go into this switch. This switch is a reverse polarity switch. It's a double pole, double throw, or DP-DT switch, and the power comes in. You can set it to forward, neutral, reverse. So if I want the lathe to run into reverse, which I don't know why I'd need it to run in reverse right now, maybe for sanding or something, but I can run my lathe in reverse with this switch. And then it's going to come out of the switch into the motor. And here we have a 2.25 horsepower Icon Health and Fitness treadmill motor. Now almost all of these builds use treadmill motors because they're relatively easy to find. I found this one online at an Overstock or something like that. So it wasn't that very expensive, but red and black wires is where your DC voltage comes in. this right here, these blue wires, are actually a switch for a overheat, for a heat sensor, so that when it gets to a certain temperature it will shut off. I don't know how to build this circuit, so I'm not going to. These wires will either be pulled out, cut off, or wrapped up somehow, but I'm not going to use these for now. If I figure out how to do it later, then I might add it back in if I want an overheat temperature, because it does get pretty hot in here in the summertime, but I don't know. So for now, these are not going to be used. Okay, so that's everything to start. Right now, I got this little control box, or this little project box that I was going to put everything in, but I don't know if this is actually sturdy enough. I'm going to try, but if not, then I will have to get a different box to put everything in and work that out. So that's what we're going to start with right now. So now I'll speed up the video and you can watch me put it all together. Also, before I forget, the wiring I'll be using is just standard house wiring. The motor is rated at 15 amps, I believe. The motor, it doesn't say, but I think the motor was rated at max 15 amps, which I don't think I'll ever get it that high. But I'm using standard household power wires that I will take the wires out and use this for a lot of the wiring. That way I know it's not going to burn out the wiring by drawing too much power. Yes, I know I should not be using a knife for this, but I was very careful, and I got proper wire strippers the next day, but I did not want to wait. Okay, so I did make one change to the schematic. This is going to be in parallel now. So this is going to go there, and that's going to go there. And this is going to go away. So the power supply is going to be in parallel with the voltage controller rather than in series. I don't think it'll work in series. So pop it in parallel and see what happens. Since it's AC voltage, house wiring, yeah, so the reason I did this because AC voltage, house wiring, all of your outlets are wired in parallel. So I figure I should do the same inside the circuit since it's basically two AC circuits. I'm just hardwiring them instead of plugging them in. So yeah, so alright. Now I'm going to set up the wiring and do a test and then put it all in the box. Okay, well, the circuit works, but I dropped the motor and bent the shaft, so it has a really nasty wobble in it now, which means I can't use this motor anymore. So I'm going to have to source a new motor, but for now I know the electronics work, so I am going to get those finished up, put into the case, and ready to go. And then in my next video I will hopefully have a new motor because I need to mount it. So hope you enjoyed this video, hope it gave you some insight on what you can do to do this yourself if you need to. If you own a Harbor Freight Lathe, eventually you might need to, unless you have a couple extra $1,000 for a good lathe, which I don't. So off we go back to searching for more treadmill motors. Anyway, again, thanks for watching. See you in next one.